Hi, my name is Linda Ortenzo, and I'm the Director of STEM programs here at Carnegie Science Center. And I'm very happy to be here with you today at the Pittsburgh STEM Summit to talk about the vital role of informal education and our collective goal of effective STEM education. As many of you know, 2 years ago, Carnegie Science Center launched the Chevron Center for STEM Education and Career Development to scale up our long-standing efforts in this field, which most of you would know as our numerous programs for students. And that would be the Inspired Learners pillar on this list. But we know that effective STEM education takes collaboration among all stakeholders, and that's really just how we work. But it also demands great teaching and a committed community. So we added these pillars to our STEM Center initiative. But there's a fundamental problem. There isn't a universal definition of STEM education that we all embrace. In fact, there's a lot of confusion about it and lots of different interpretations. So here are just some of the variations that we've seen. If you think about it, there's STEM, STEAM, STREAM, STEM, and STEAM. For a lot of people, we hear from them that all of this alphabet soup confusion makes them want to scream, and we get it. So recently, Carnegie Science Center put forth a working definition of STEM education, and we really are interested in exploring this definition and hopefully seeing it be adopted broadly and nationally. It includes these components. The best practices that research can support in inquiry-based science and math education, integrated curriculum, project-based group learning, and career awareness. For many of you, this is going to be a very common list, but we really think that the combination of this is integral. So to give you a little bit of detail about this, I wanted to just give you just some specifics about each of these components and then cite an example of a program that we do that we feel really embraces all of these. So with inquiry, this is integrating proven strategies that emphasize curiosity and hands-on exploration. With integrated curriculum, teachers planning curriculum together. This is not something that's common to them, but something that we feel is extremely important because the real world isn't siloed by subject, and so education shouldn't be either. Project-based group learning gives students an opportunity to solve real-world problems by applying math and science and to develop their own 21st century skills like teamwork and good communication. Regarding career awareness, we always provide opportunities for students to interact with STEM professionals and explore a possible future for themselves. So as promised, here's an example of a program that we do that we feel really embodies all of these components. Future City is a national engineering competition for middle school students, which can be done as part of school curriculum or by informal science education groups as an after-school initiative. This is where 6th through 8th graders get to work with teachers and engineering mentors to design a city of the future. They use SimCity software, they write an essay on an annual theme, and they build and present a scale model of their future city to engineers who not only judge them, but also engage them in conversation about their interests and talk to them about what engineers do and how engineers transform our lives. So I wanted to share some research with you on the impact of this program. This was done nationally with more than 2,000 students and more than 1,000 teachers, parents, mentors, and regional coordinators. What they found was that 80 to 90% of the respondents said that the program increased the students' ability to work in teams. This is a fundamental 21st century skill. In addition, a very high percentage saw improvement in students' ability to do public speaking, project management, work independently, and do writing and research. Again, these are cross-curricular skills that are extremely important and essential for 21st century success. In addition, an average of 85% of teachers, parents, and mentors saw an improvement in students' abilities to apply engineering design skills to real-world problems. And about 80% of students said that Future City taught them why math and science are important to their futures. And nearly 60% of the students said this program helped them to see themselves as engineers someday, and it also made them want to do more activities like this. That was just a powerful example of the importance and the vital role of informal science education in the overall collective goal of effective STEM education. And now my colleague Alana Kalesa, the Director of Strategic Education Initiatives at Carnegie Science Center, will share with you some of our initiatives regarding two other pillars, the Great Teaching and Committed Community initiatives. Alana.
Thank you, Linda. Well, as Linda mentioned, it is a great priority for the Carnegie Science Center to support educators, both formal educators, informal educators, and parents and families. So one effort that we are undertaking to create this systemic change through our Great Teaching pillar is our STEM Education Pathway Project. This initiative is helping us work with schools and teachers because we know they can't do it alone, and we want to help them lay out a progressive pathway to achieving success. So the education pathway we're working on is going to define measures of success. What does it look like to do STEM education right? And how do we get there? What are clear milestones that we can achieve to move ourselves forward in this journey? So one way that we're doing this is by asking educators themselves. We're working very closely with regional school districts as well as representatives from higher education, universities and colleges in our region, and community organizations that are key stakeholders in the economic success that comes from our STEM literate workforce. The key priorities have all been developed by the stakeholders at the table, and they're working currently to develop a tool that will be an evaluative rubric to measure this pathway to excellence. As we move the STEM Education Pathway Project forward, we are going to have districts that are in our region test it out for us. They're going to pilot this evaluative tool and give us feedback to refine it further. We're also going to be gathering feedback on how to incentivize this initiative and really encourage it to be used more broadly throughout our region and beyond. Another key pillar that we focus on is this committed community that we are all a part of. It takes both educators, parents, family members, community organizations, informal and formal educators together to really move STEM education forward. And we want to make sure that all stakeholders have access to resources that will help them do so. To this end, we've developed the STEMosphere, which is a portal to the universe of STEM opportunities, particularly in southwestern Pennsylvania. The STEMosphere is an online information source which provides a portal for parents, educators, students themselves, and community partners to find after-school programs, events and competitions, online education tools, and a variety of other resources that are all extremely pertinent to STEM activities in our area. The website is actively live now, collecting information about resources, and currently we have several hundred resources in the directory and representing dozens of organizations. Each day that we work on this project, it grows and expands, and we're hoping to launch this more broadly in the community early in 2014. So we look forward to sharing that this spring. The community launch, as I said, will happen in the spring, and we're not slowing down. So there's a lot of work to be done, and on behalf of Linda, myself, the entire Chevron Center for STEM Education and Career Development team, and all of us at Carnegie Science Center, we thank you and look forward to working together.